Hello guys, my name is Akshans and welcome to CADDD Academy. In this lecture we will discuss the Gauss law. So as we know guys, which is what? Electric flux density. Okay, so we know that electric flux density is flux per unit area. Okay, so if we are considering a small amount of flux and a small amount of area, which is dA, so let's write d here. Okay, so this is electric flux density, and which is equal to a small amount of flux per unit small amount of area. Okay, now let's take this dA to that side. Okay, so then we will have dA, which is equal to a small amount of electric flux. So let's integrate both sides. So here we have surface integral of electric flux density, and here we have just electric flux. Okay, so integration and differentiation gets cancelled out. Now here we need to introduce the Gauss law, which says that the net electric flux coming out of any closed surface is equal to the total charge enclosed by that surface. So this is what a Gauss law says. So let's write it in the form of equation, which will be more simplified. Let's say this is net flux. Okay, net flux, which is equal to Q enclosed. Okay, charge enclosed. So let's use this equation. Let's say this is equation number 1. So let's use this equation here. So we can write closed surface. Okay, this is closed surface. Now the electric flux is equal to this thing, but when we are considering the net electric flux, we have to show the closed surface. Only a closed surface can have net electric flux. Okay, so this is the thing which is known as Gauss law. Okay, so this is Gauss law, but this Gauss law is in integral form. Okay, integral form. Okay, so to get the Gauss law in point or differential form, let's consider we have a spherical. Okay, let's say we have a spherical object, and inside the spherical object there is a charge density of, okay, volume charge density of rho v. Okay, so this is volume charge density. Okay, so keep in mind this is charge density. Okay, and this d is electric flux density. Okay, a lot of guys gets confused in this, but you don't have to. Okay, this is flux density and this is charge density. So this is the charge density rho v. If we will multiply with the volume, same volume v, okay, then we will get the charge enclosed. Okay, then we will get the charge enclosed by that volume. Okay, this is the volume integral. So this is the charge enclosed. We'll put this charge enclosed into this equation. Okay, then we will have closed surface integral of electric flux density, which will be equal to volume integral of charge density, this thing. Okay, so according to Gauss theorem, we know that this thing, surface integral, closed surface integral, is same as the divergence of the field and get the volume integral of that thing. Okay, so divergence of the field and get the volume integral of that field. So we got this thing here. So let's cut out the volume integral both sides, then we will have divergence of electric flux density equal to charge density. Okay, so this is the Gauss law. Okay, Gauss law in point or differential form.